Okay, so now that we've explored this goodness of fit and chi-square distribution, let's go over the formal steps for the test and the conditions, okay? So the null is always that the counts match the given distribution, okay? And our test statistic, just like we've seen, is a measure of how far the counts are off from the expected, relative to each expected group size. Okay, so that's our chi-squared test statistic. So steps for a goodness of fit hypothesis test with a chi-square distribution, and this is called the goodness of fit test. Okay, so our steps are just like you're used to, write the null and alternate hypotheses. The null is uniform, meaning all the same, or matching a distribution, okay? And the alternate, so that's the null. The alternate is at least one proportion is different. Okay. Realize I'm kind of using counts and proportions, so our hypotheses are written in terms of proportions, but the data we have are usually counts, but we can also turn those counts into proportions, right? Okay, so then we will check the conditions, which I have listed below. As always, check the conditions. Then we'll calculate our test statistic. The chi-squared is equal to this summation. That's the one we already practiced. Observed minus expected squared over expected, and we add those together for each term. And then the degrees of freedom is the number of categories minus 1. Okay. Then we use the chi-squared calculator to find the p-value with those with that degrees of freedom. It's always a right tail test, so that's kind of nice. Okay, then as you're used to, we compare the p-value with the significance level, determine whether the result is statistically significant, and state the conclusion in context, including the p-value and whether we reject or fail to reject. Okay, so very similar steps that you're used to. Here are the conditions. Okay, so here's a new one. Counted data. The data must be for counts for the categories of a categorical variable. Okay, it's possible someone might have a different kind of data and try to use a goodness of fit test, but it doesn't really work because they're not actually counts. Okay, so that's important. Always double check that. Independence. The individuals counted must be independent of each other regarding the variable measured, so that is very similar to what you're used to. Randomization, we have the data from a random sample, also very close to what you're used to. Large population, if sampling without replacement, the population must be 10 times the size of the sample. You're also used to that. And then there's usually some kind of sample size or success failure, right? This one has to do with expected counts. So the first and the last are kind of different. The expected counts should all be at least 5. Okay, so let me find our expected counts page. This is where we calculated the expected counts. So these would all need to come out to at least 5. So that we're safely meeting this condition. The smallest one is 14, but so I'll make a note. Greater than or equal to 5. This is the meets the expected counts. Can you see that? Yeah, condition. Okay, so feel free to go back and add that note. Each one has to be greater than or equal to 5. Okay. Okay, and of course you can also check that in stat key as well. Okay. Great. So I haven't written out the conditions for this one in full, but you'll get practice writing out the conditions in a practice problem. Let's talk about one more thing, and that is something called standardized residuals. Now this is important because if or when we reject the null hypothesis, we still don't know which category or categories we're off, right? It doesn't tell us. It just tells us at least one is different. But maybe we want to know. We don't know which ones. In order to find out, we can calculate and compare the standardized residuals. Okay, now this is going to look familiar. We have observed minus expected over the square root of expected. And we use a lowercase c for this. I'm not really sure why. This is really the square root of the contribution to the chi-squared statistic, right? Because we had the numerator was squared, and this didn't have the square root. So if we squared both of these, we would get the contribution. But let's calculate a couple of these so we can see what's going on. So let me put A for Asian right here, and I've got my table right here that I'm going to read off from. Okay, I could also use it from my chi-square calculation because I've got it written there. So 384 minus 217.95 over the square root of 217.95. Okay, I'll do this one on my calculator. Why not? 384 minus 217.95. Now I need to either hit enter, oops, too much glare. I need to either hit enter, or just like a z-score, because I want the subtraction to come first and then the division, or I need to do parentheses. I'm going to hit enter and then divide that by the square root of 217.95. Okay, and I get 11 point, I'm just going to do 2 digits for these, 11.25. Okay, you see how that works? Try the rest. You can pause this video, try them, and come back and double check. So for black, we should have 117 minus 261.54. Now, of course, you can kind of eyeball the differences, right? Like this one, but when they're all different numbers, it is just kind of hard to tell. So this standardized residual it gives us a nice measure for which ones are off. Divided by the square root of 261.54. 117 minus 261.54. Enter. See, we're getting a negative sign because we're not squaring. In this case, we might want to know, right, is over or under. So that is also very useful. So then, oops, I need to divide by the square root of 261.54. And I get negative 8.94. Okay, so try these all out yourself. I'm going to put in what I got for the rest of them. I got negative 4.57 for Hispanic, negative 0.16 for white, and 11.40 for other. Okay, so we can interpret these kind of like a z-score, where within 2 is usual and outside of plus or minus 2 is unusual. Okay, so treat this like, or interpret it like a z-score, a value, or you could say absolute value without the sign, a value greater than or equal to 2 is unusual. I'll say absolute. Okay, and then a plus, if it's positive, that means your observed is more than expected, right? So that means overrepresented. Okay, so that means folks of Asian descent and other were overrepresented. A negative means our expected was, our observed was less than we expected. Let me say it that way. Observed was less than what we expected to make that negative, so that means under. Underrepresented. And we can tell by how much, right? We can see that black folks, African American folks were the most underrepresented, followed by Hispanic. White is pretty much right on, okay? Okay, great. So that's how you can tell a really good measure for telling exactly which categories are off and by how much. Okay, great. Thanks for watching. I'll see you in the next video.